Hi, here I've got a second video over the rational root theorem. So we're just going to practice using the rational root theorem. So if I look at this given polynomial, it looks like we have a fourth degree polynomial, so I can see that right there. And so what we're going to do is, depending on how I define these values, sometimes you'll see this referred to as P and this referred to as Q. But basically it's going to be the factors of this value divided by the factors of this value that will make up our possible rational roots. So our possible doesn't mean these will all be roots. Possible roots are going to be factors of 12 over factors of 1. And so that's going to be the same thing as, and we got to do positive or negative. So our factors of 12 would be 1, 2, 3, 4, 6, and 12, which is quite a few, but the good news is that our factors of 1 are just 1 and 1. So it's going to be positive or negative 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1. So I'm just going to write those out. And so I've written those out down here. So it looks like we have 1, 2, 3, 4, 5, 6. So we have 12, if you count the negatives, possible roots to try with our guess and check. And so now let's just jump into that guess and check. I'm going to use our polynomial right here. And I'm just going to use all of the coefficients and do synthetic division. So starting with a 1, we're going to have 1, 2, negative 7, so on and so forth. So 1, 2, negative 7, negative 8, and 12. And let's just start with a negative 1. Let's just try that first. I'm going to try a negative 1 first as a possible root. And so I'm going to kind of fly through the synthetic division here. I add straight down. Then I multiply by negative 1. I add straight down. I multiply by negative 1. I add straight down. I multiply by negative 1. And then I add straight, and then I add straight down. Because we have a remainder that's not 0, that means that negative 1 is not a root. Remember, these were just our possible rational roots, but that doesn't mean that they all are going to be roots. And so this negative 1 we find doesn't work. So I don't like the 1. And so I'm going to do, and you can show this however you want, I'm just going to erase that little minus sign to show, okay, we tried that, wasn't for us, didn't work. And so let's just go, let's go to the positive 1 now. So I don't have to erase everything. I'm just going to kind of back up and see if I can do this and keep everything else there. Let's see here. Okay. And now we're just going to try the positive 1, and we're going to see if it works. So if I bring down my 1, 1 times 1 is 2, add straight down. 4 times 1 is 4, add straight down. Negative 3 times 1 is negative 3, add straight down. Oh, and I messed up somewhere because this is supposed to work. So yeah, let's just fly through it. So I bring down the 1. 1 times negative 1 would be negative 1, and then I add straight down and I get a positive 1. 1 times negative 1 is negative 1. Add straight down, I get a negative 8. Negative 8 times negative 1 is positive 8. Add straight down, I get a 0, and that did not work either. So I'm going to change that to a positive 1 because now we're trying this positive 1 here. And let's play the same game. So I'm going to bring down our 1. Oops, I'm still in eraser mode. Bring down our 1. 1 times 1 is 1. Add straight down. 3 times 1 is 3. Add straight down. Negative 4 times 1 is negative 4. Add straight down. Negative 12 times 1 is negative 12. Add straight down. And now we get the 0 remainder that we want. Okay? So we have used the rational root theorem to identify our possible zeros. The negative 1 didn't work, but the positive 1 did. That means that 1 is a 0 of this polynomial. So maybe I'll kind of come over here to the side, wherever I want to write it, and write that 1 is a root. It's one of our roots because we had a remainder of 0. But now what we do is we keep going with our reduced polynomial. Okay? So if this was a fourth degree polynomial, that means this is going to be a third degree. It reduces the power. So this is x to the third plus 3x squared minus 4x minus 12. But basically I can just take that and I'm going to kind of copy it down here. And let's keep going. as far as knowing what to guess now, notice we still have factors of 12 over factors of 1, so you could just keep trying all your same roots. And the other thing that I want to say is just because you used a 1 once, that doesn't mean it's not necessarily going to work a second time. So you may want to try that again, but we don't want to try the negative one. We already established the negative one does not work. So let's just pick another number, and I'm just going to kind of jump into it. So let's pick, let's move on to our 2. So 1 times 2 is 2, add straight down. 5 times 2 is 10. Add straight down. 6 times 2 is 12. Add straight down, and we got another winner. So that means we can come over here to our winners list, and if 1 is a root, we also found out that 2 is a root. Okay? And then we could keep going with our rational root theorem, but now we've kind of gotten what's left down to a quadratic. So notice we reduced it from a 4th degree polynomial to a 3rd degree polynomial. And then we reduce from a 3rd degree polynomial to a quadratic. That means if I were to take this and actually write out the reduced polynomial, I'll come out over here and do this part in blue, it would be 1x squared plus 5x plus 6. And this is the quadratic function that we're dealing with now. And so while you could keep going with rational root theorem, at this point, when it's quadratic, I think it's going to be easiest just to factor. And so if I'm looking at my factors of 6 that add up to 5, it would be this, and so therefore our roots would be whatever make those factors equal to 0. So that would be a root of -3, and that would be a root of -2. The way I got those, I used an idea called a rational root theorem, and so you may want to look up that if you're not sure where I got those. And so what we have is we have a 4th degree polynomial. It's going to have at most 4 real roots. And we found our 4 roots, 1, 2, -3, and -2. So kind of remember those. I'm going to make this go away, and we're going to look at a graph real quick to confirm. But 1, 2, -3, and -2. So what I'm going to do now is I'm going to pull over handy dandy Desmos, where I've already got this function graphed. And you can see here's the function we started with, and you can see our roots. 1, 2, -3, and -2. So just by graphing it, we can kind of confirm what we just figured out with all that math. So, oops, let me pull up that PowerPoint again. All right, and let's keep going. So here is our next example. It says we're going to find all roots of this polynomial. And so let's first by figuring out what our roots are. And our possible rational roots are going to be factors of this over factors of this. In other words, we have factors of 3 over factors of 3. So if I were to write that out, this means we're going to have positive or negative. Well, the only factors of 3 are 1 and 3. And then we have a 1 and 3 here. So what we're going to do is we're going to write out all of our possible rational roots to start our guess and check. We're going to have positive 1, negative 1, positive 1/3, negative 1/3, positive 3, negative 3, and then we have another positive 1 and negative 1 because 3 over 3 is the same thing as 1 over 1, so we can just kind of leave that one out. So let me kind of write those out real quick. Okay, and so you can see what these are kind of all of those possible rational roots that we just found in fraction form, but I can kind of simplify each of them. So we're going to turn this into just positive or negative 1, and we're going to turn that next one to positive or negative 1/3. And then we have positive or negative 3. And you can see right here, this is just another, I want to emphasize that, that's just the same thing as this over here. 3 over 3 is the same thing as 1 over 1, so we don't have to do that. So we really only have 6 rational roots here. And so what I'm going to do is I'm just going to jump into it. So if I kind of come down here, and I'm going to write down all of my coefficients. So we have, looks like we have 3, 9. We have an invisible 1 right there as a coefficient to the x. And then a 3. I'm just going to pick, let's start with our negative 1. So if I start with negative 1, here we go. 3 times negative 1 is negative 3. Add straight down. 6 times negative 1 is 6. Add straight down. 7 times negative 1 is negative 7. Add straight down. Well, what we see is that we got a 0, or excuse me, we find that negative 1 is not a 0. So I can kind of, I'm going to come up here and just erase the negative to show that we've tried that. I'm going to kind of take it out of my guess and check. And let's just kind of keep going. Remember, we're looking for a remainder of 0. to prove that it's a root. Now for the sake of time, since I already know what the answer is, I'm going to jump to trying out -3. I'm going to jump to -3, so I'm not wasting your time doing a guess and check for forever in here. So 3 times -3 is -9, add straight down. 0 times -3 is 0, add straight down. 1 times -3 is -3, add straight down, and you get a 0. That means that because there's a remainder of 0, that means that -3 is a root. So we have that -3 is a root. Okay? So we've got one of our roots. We know this is going to have at most 3 real roots. Okay? And so let's go and find the next one. Now we've already got this down to a quadratic. It's 3x squared plus 0x plus 1. So I'm going to kind of do what we did last time. I'm going to look at our quadratic. 3x squared plus 0x plus 1. And if I'm looking at this as a function, if you want to call it, you know, your reduced function g of x or whatever you want to call it, I don't care. But because it's quadratic, we don't have to keep going with rational root theorem. And so you might say, okay, well, let's factor it. And you might try to factor it and you find that it doesn't factor. And then you say, okay, let's try quadratic formula to figure out the roots. And if you do quadratic formula, you're going to find that you get a negative discriminant. Basically, where you would end up is you would find that this quadratic has no roots. Which means that this polynomial has no roots other than the -3 that we found. Okay? And once again, I'm getting there because I'm saying that this reduced polynomial that we found, that I'm rewriting as a polynomial here, it doesn't have any roots. So that means we really only have one real root to this function, okay? And I'm not going to go too much into detail about the real roots versus the complex roots or anything like that, but what I do want us to do is I want us to take a look at the graph of this one. So I'm going to make our stuff go away, and I've got a graph of it over here on Desmos. And I've graphed our function right here on Desmos, and so you can see I've got it graphed, and we found that -3 was a root, but there's no other places where this function crosses the x-axis. So there's really only one real root of -3, and as we're going to find in later videos, this is going to have a couple of complex roots, but we're going to stop there for now.